Okay, so we at this point have now finished reviewing a lot of the algebra basics that you're going to need as we go through this year. So we have reviewed things like the order of operations and how to use that to get answers to problems. We have reviewed distributive property and combining like terms, and we've talked about how to use those things to simplify expressions. And we definitely will continue to use those skills. What we're going to do today is move on and review another skill in Algebra 1 that is very, very, very important. In this next chapter, we are going to be solving equations. So we're going to be solving equations. And as we solve equations, we're going to start out very, very simple with one-step equations. Then we'll work our way up to two-step, three-step, four-step, and finally we will have five-step equations. So as we go through this chapter, you definitely want to be sure that you understand the basic equations because we're going to be building on those as we go. So let's talk about some equation rules. And I guess even before we talk about those equation rules, we need to remind you that equations have equal signs. So a problem is an equation if it has an equal sign, and you're going to see stuff like 2x plus 5 equals 15. And your job is going to be to solve that. And you all will remember that means that you want to figure out what that x is in that equation. So that's what we're headed into here. So let's talk about equation rules. The first rule that I'm going to give you for equations is every single time you start to solve an equation, I want you to draw a line through the equal sign. And I'm going to ask you to draw the line through that equal sign to show you that an equation has two sides. So if you draw that line through the equal sign, it nicely divides your equation into its two sides. Now, that kind of goes along with rule number 2, and out of all of them, this is probably the most important one to me. When you are solving equations, whatever you do to one side of the equation so whatever that may be, you must do it to the other side as well. So we're going to draw that line through our equal sign to show the two sides of the equation, and we are always going to remember that whatever we do to one side of that equation, we are going to do the same thing to that other side as well. We have to do the same thing to the other side as well. Now, we're going to spend a lot of time with equations talking about undoing things. So I need for you all to know that in order to undo something in an equation, you are going to use the opposite operation. So as we go through this chapter on solving equations and we talk about undoing things, in order to undo something, you are going to use the opposite operation. And then finally, the last thing that we want to talk about here is that when you're solving an equation, the goal is to get the x by itself. The goal is to get x by itself. So when we solve equations, we're going to draw a line through the equal sign so that we can clearly see the two sides. We are going to remember that whatever we do to one side of that equation, we have to do the exact same thing on the other. We're going to remember that if we need to undo something in an equation, we're going to do the opposite operation. And we're going to remember that the final goal, the big goal, is to get the x by itself. So these are our rules for solving equations. Now today, we are going to be focusing on one-step equations. We're actually going to do a couple of days of this. And when we talk about one-step equations, what I need you to know is that they contain one operation. One operation. Now when I say they contain one operation, what do I mean by that? What are operations? Well, in math, our operations are add, subtract, multiply, and divide. So when we solve one-step equations, what we are going to be seeing is equations that contain one of those operations. Add, subtract, multiply, or divide. And to solve these one-step equations, what we are going to have to do is we are going to have to undo that operation. Undo that operation in order to get x by itself. So this is where that rule comes into play about to undo something, you do the opposite operation. So if your equation contains addition, then you're going to need to do the opposite of addition, which is subtraction. If your equation contains subtraction, you're going to need to do the opposite of subtraction, which is addition. If your equation contains multiplication, you're going to have to do the opposite of multiplication, which is division. And then finally, if your equation contains division, then you're going to have to do the opposite of division, which is multiplication. So one-step equations are going to contain one of the four operations, and you're going to undo that operation by doing the opposite to get that x by itself. So let's look at some of these problems and talk about how this goes. All right, so we're going to start out nice and easy. We are going to solve the equation x plus 5 is equal to 8. Now, a lot of these equations that we're going to be doing today and tomorrow are going to be simple enough that you can look at them and you know what the answer is. But I want you to actually go through the steps. I want you to do the work so that as they get tougher, you're ready for that. All right, so remember, the first rule that I wrote down for solving an equation is I want you to draw a line through the equal sign. Remember, the purpose for that is it shows us the two sides. X plus 5 is one side of my equation, and 8 is the other. So this equation tells me that when I take x and add 5, that I'll get 8 as my answer. Now, real quickly here, remember what our goal is. Our goal is to get this x completely by itself. So in order to get this x completely by itself, think about what needs to go away. Well, to get this x completely by itself, this plus 5 needs to go away. So remember, this is called a one-step equation because there is one operation. So I want you to look at this equation, and I want you to look to see what operation is in it. Well, my x has 5 being added to it. So add 5 is the operation that I'm seeing done in this equation. If I want to solve, then I need to undo that. And I undo adding 5 by doing the opposite operation. What is the opposite operation for adding? Exactly, subtracting. So if I want to solve this for x, what I'm going to do is I'm going to come down here below this add 5, and I'm going to do the exact opposite, which is subtract 5. So when I see plus 5, I'm going to say, okay, the opposite of that is minus 5. And then remember that other rule, that second rule that I wrote down that I told you was so important. If I do it to this side of the equation, then I have to do the same thing on this side of the equation. So if I'm going to do minus 5 on this side, I got to do minus 5 on this side as well to keep this thing balanced. So I'm trying to get this x by itself. So I look to see what's being done to x. Well, 5 is being added. Add 5 is what's happening. So I do the opposite, which is subtract 5. And then I come over to the other side and do that same thing as well. Now what's going to happen is that this add 5 and this subtract 5, this add 5 and this subtract 5 are going to cancel each other out. So when they cancel each other out, the only thing left on this side is the x, which is what I wanted. I wanted that x to be alone. And then on this other side, here's where the answer is going to show up. 8 minus 5 is 3. So according to the work that I just did in this equation, that x should be a 3. So can I check that? Well, sure I can. So to check that, here's what we're going to do. We have our equation x plus 5 is equal to 8. And we now believe that that x is the number 3. So I'm going to substitute a 3 right here where that x is. So that'll give me 3 plus 5 equals 8. What is 3 plus 5? Well, 3 plus 5 is 8. So I end up with 8 equals 8. That's true. 8 is equal to 8. So that checks, that balances. So x equals 3 would be the solution. So notice, we drew that line so we could see the two sides to the equation. Our goal is to get that x by itself. So I have to look at what the equation says is happening to him. Adding 5 is what's happening to him. So to undo that, I have to do the opposite operation. So instead of add 5, I want to do subtract 5 to cancel that out. And if I do it to one side, I have to do it to the other. All right, so that's a basic one-step equation. All right, let's try another one. Let's solve m plus 9 is equal to 2. Now again here, first thing I want you to do is draw that line through the equal sign. Your goal is to get m by itself. So what I need to do is look to see what operation is happening to m. What is this equation doing to m? Well, it says it's taking m and it's adding 9. M plus 9. So add 9 is what's happening to m in this equation. Well, if I want to solve, then I need to undo adding 9. I need to undo that adding 9, because that'll cancel this out and get that m alone. So what will undo adding 9? Well, what will undo adding 9 is subtracting 9. And then if I do it to one side of my equation, I have to do it to the other. So I'm going to subtract 9 on each side in order to undo that adding 9. Now, here's what will happen. The adding 9 and the subtracting 9 will cancel each other out. So on this side, all I have left is that m. What's that equal to? Well, I need to do a little math to find out. 2 minus 9 is what I got to do. So the m in this problem should be a negative 7. And again, we won't do this every single time. But here in the beginning, it's a good way to make sure you're doing it right. We had the equation m plus 9 is equal to 2. We now believe that this m is negative 7. So we're going to put negative 7 where m is and see if that works out. Negative 7 plus 9 is 2. I get 2 equals 2. That checks out. So if you're ever in doubt about whether you've done an equation right or not, that's a good way to check yourself. Okay, so next up, let's try this. All of these equations are going to be nice and simple, one operation for you to deal with. So we're going to solve y minus 4 is equal to 3. First, draw your line through the equal sign. And then keep your mind on what your goal is. Your goal is to get y by itself. So the question for you ought to be, what is happening to y? What is this equation doing to y? Well, it says that the equation is taking y and it is subtracting 4. So that's the one operation that this equation is doing. It is subtracting 4. So I have to undo that. So if I see subtracting, what will undo that? The answer is addition. So to get rid of subtracting 4, I want to do the opposite operation and add 4. So to undo subtract 4, I'm going to add 4. And then if I do it to one side of my problem, I have to do it to the other. Now, here's what happens. The subtracting 4 and the adding 4 cancel each other out. So on this side, all I have is my y. That's what I wanted. I want y to be by itself. On the other side, I have my answer. 3 plus 4 is 7. So the y in this equation should be 7. So let's check it. If we did 7 minus 4, would we get 3? And the answer is yes. So that checks. That is correct. So notice what we're doing here, folks. We are looking at our equation and we're trying to determine what is happening to that x. What is that one operation that's being done? And once we figure out what that one operation is, we undo it by doing the opposite. So take a look at this one. We're going to solve w plus 3 is equal to a negative 4. Draw your line through the equal sign. Remember your goal. Your goal is to get w by itself. So look at the equation and ask yourself, what is the one operation that is being done to w? What is the one thing that is happening to w? Well, it says they're doing w plus 3. So adding 3 is what this equation does to w. So if I want to solve it, I have to undo adding 3. So what operation will undo adding? Subtracting. So to undo adding 3, I'm going to subtract 3. And if I do it on one side, I have to do it on the other. So I'm going to subtract 3 over there as well. Now, my add 3 and my subtract 3 cancel. So I have w equals, that's what I wanted. I wanted w alone, and now I have it. Negative 4 minus 3 is a negative 7. So in this problem, w should be a negative 7. All right, let's try n minus 6 equals negative 7. Draw your line through the equal sign. Remember, your goal is to get the variable, which in this case is n, by itself. So I need you to look at this equation and think about what is the one thing that's happening to n. What is the one thing this equation is doing to n? Well, it's taking the n and it's subtracting 6. So subtract 6 is what I have to undo. To undo subtracting, I would add. So instead of subtract 6, we're going to add 6. If we do it on one side, we do it on the other. Subtract 6, add 6, cancel each other out because they are opposites. N is now alone. Negative 7 plus 6 will give me my answer, which is negative 1. So notice, on every single problem, we are looking for what is happening to the variable, what operation is happening to the variable, and we are doing the exact opposite. Now, we've done several. Let's write the equation in a way that's a little bit different, just to show you that this same technique will work on any of these equations. You have here negative 14 is equal to p minus 11. You are still going to start out by drawing your line through the equal sign. You are still going to remember that you want to get P by itself, that is the goal. So we need to look at this equation and ask ourselves, what is the one thing this equation does to P? Well, it tells you it does P minus 11. So the one thing that this equation does to P is it subtracts 11. So that's what you have to undo. That's what you have to undo. To undo subtracting 11, you'll use the opposite operation, which means you will add 11. If you do it to one side, you do it to the other. This subtract 11 and this add 11 cancel each other out. So now you have P all by itself over here, which is what you wanted. That is equal to negative 14 plus 11, which is a negative 3. So notice the answer does end up kind of backwards, but the steps are the same. We are doing exactly the same thing. Okay, let me show you just a couple more things. And again, this is all in the name of just making sure you see how these could be written differently. Okay, so let's say that I have 4 plus x is equal to 9. 4 plus x is equal to 9. Now, you'll notice what makes this one a little bit different is the fact that usually we have the variable first. Usually we have the variable first. Okay, so we're going to do the same thing. We're going to draw our line through the equal sign. So we'll start with that. We're going to keep in mind that we want to get this x by itself. So we need to look and see what is the one operation that this problem is doing to x. Well, you can see that it's x plus 4. This 4 right here is positive. There's a plus sign in front of it. So this is adding 4. That's adding 4. So that's what I got to undo. So how would I undo adding 4? Well, I would subtract 4. If I do it to one side, I have to do it to the other. This add 4 and this subtract 4 cancel each other out. So I have my x all alone. And on the other side, 9 minus 4 is 5. So I want to point out to you here, no matter how they rearrange these equations, no matter how they rearrange, if you will stick to the same set of steps, you will get through these just fine. All right, let's look at one last one. Let's say I have negative 5 plus x is equal to a negative 10. Negative 5 plus x is equal to a negative 10. All right, line through our equal sign. That's always our first move. And then we remember what we're trying to do. We want to end up with x by itself. So I need to look at that side where x is located and think about what's happening to him. We have x plus a negative 5 minus 5, negative 5. This is like subtracting 5. A negative 5 is like subtracting 5. So in this problem, you are actually taking that x and subtracting 5 from it. A negative 5 and subtracting 5 are one and the same. So when you see this negative 5, think of that as subtracting 5. Now, what will undo subtracting 5? Well, the answer is adding 5. So we're going to add 5 to one side. And if we add to one side, we have to add to the other. So our subtracting 5 and our adding 5 cancel each other out. X is left alone, which is what you want. And then negative 10 plus 5 will give you your answer, which is a negative 5. So x is a negative 5. So on all of these problems, let me take you back just a minute to the very beginning. Your equation rules. On every single one of these, I drew a line through the equal sign to show my two sides. I remembered this rule that whatever you do to one side of the equation, you have to do the exact same thing to the other side as well. That in order to undo something, whatever that something was, I used the opposite operation. So if I saw adding, I subtracted. If I saw subtracting, I added. And I remembered that the goal is to get x by itself. And all of these equations that you're going to be solving today are one-step equations. That means they're going to contain one operation only. So there will be adding, subtracting, multiplying, or dividing, only one of those in the problem. And whichever one of those you see, you undo that operation to get x by itself. So if the problem is adding 5, you subtract 5. If it's subtracting 8, you add 8. Notice we didn't do any multiplying or dividing. We're going to save those for tomorrow. So on every single problem you solve today, the problem will either have adding a number or subtracting a number in it, and you will do the exact opposite in order to get that x by itself. If you have questions, please let me know, because remember, this is a building process. So we're going to start out with these simple little baby one-step equations and work our way up to multi-step equations. So any questions, let me know.